Lesson 10 we've kind of already done, or at least we've talked about it. We're just going to kind of make it a little bit more formal. You remember when we first started doing equivalent ratios and making tables, we were looking at patterns when you go from one row to the next row? Does that ring a bell?
Yeah.
This kind of builds on that a little bit and kind of formalizes it. So if you guys can go to page 3, we'll start there. We're going to build a ratio table together. Let's just read the directions. I'm going to read it out loud. Imagine that you're making fruit salad. For every quart of blueberries you would like to put in 3 quarts of strawberries. What's our given ratio? Put it over here. What's our given ratio? Julia, does everybody see 1 to 3? Every quart of blueberries is 3 quarts of strawberries. Put that right there. And let's make it our first ratio in our table. And now you're going to build equivalent ratios, and the only thing that they're asking you as somewhat of a guideline is that the amount of blueberries has to be less than 10. Okay, so keep it simple. Build your equivalent ratios based on the value of the ratio 1 to 3, and then I'll call somebody up and you can do it. All right, go ahead, John. How many of you have it like this? Did anybody do anything different? All right, well, that's kind of good that we all did the same thing. There is other possibilities. As long as the amount of total quarts of blueberries was under 10, you could do 6 to 18, 7 to 21, but most everybody does it like this. What'd you do?
Oh, I did like 3, 6, 12, 24, 48.
Let me take a look. Okay, you're not in the 1 to 3 ratio. So that second column, those numbers are not correct. Watch. Look, you know what? Keep it like that and you'll see why it's wrong. Okay, we're going to look for patterns as we go down the column. This first column, what pattern do you see as you make your way down? Well, okay, everybody add that to your table 1. We have what's called an additive pattern or an additive structure of +1 on the left side. What's your additive structure for the left side?
I did 2.
Coming down this way? I thought you had 1, 2, 3, 4, 5. No?
Oh, wait, I put them in on this side.
On the left, you're okay, right?
Yeah.
Okay. Everybody, what is your additive structure as you make your way down on the right side? Angelina.
Okay.
Okay, that's an additive structure of +3. What was yours? Not times. I need to know what you're adding by.
Then
Here to here. Let me get back to that. Let me get the phone. All right, Franco, going back to yours. When you go from here to here, what are you adding by?
3.
+3, right? It would have to be +3 here, and it's not.
Oh.
If you take your 6 plus 3 is?
9.
9 plus 3?
12.
12 plus 3.
15.
Fix it now. Okay? Because you can't multiply as you go down. As you see, you can multiply as we go across, but not going down. Okay, once again, this is what's called the table's additive structure. Everybody say additive structure. For the first column, we're adding by ones. Let's put this on that line. I'm doing what on the right? Adding by how much?
3.
Add 3 on the right. So the additive structure is a +1 and a +3. Okay, now what we're going to do is take a look at the multiplicative structure. In order to do that, we're not comparing as we go down the column. We're going to take a look at what's happening as we go across the row. To get from 1 to 3, what are you doing? Liam, multiplying by 3. To get from 2 to 6, what are you doing?
Multiply by 3.
3 to 9. 4 to 12. 5 to 15. That's why they call that a constant. Constant means always the same. So the multiplicative structure of table 1 is multiplying by how much? Say it out loud. Multiplying times 3. And that goes there. Once you know what the additive pattern is and what the multiplicative pattern is, you can find any equivalent ratio. So what they ask you to do here is, what if you have seven quarts of blueberries? How many quarts of strawberries would you need for that? Now you could either, if you know the multiplicative and additive patterns in your head, you could do it in your head, or extend the table, even though there's not enough room here. Here's 6 quarts, and here's the 7 quarts that they're asking for. So 7 quarts of blueberries means how many quarts of strawberries? Antonio, how'd you do it?
Well, I knew that 5 quarts of blueberries was 15 quarts of strawberries. So then I knew 6 was 18, and then 18 plus 3 was 21.
Okay, so you technically used additive structure. You added 3 to 15 and 3 to 18 and got us 21. What else can you do? Liv.
And then do, for the quarts of strawberries, 3, 6, 10, 12, 15, and then do times 6, do 15, 18, and then 21.
Okay, so you're still adding by 3s. How would you do it, though, using multiplication? Joe?
7 times 3.
7 times 3. Because no matter what you have on the left, you're multiplying by 3 to get it on the right. Both of them are good strategies. There's no one right way to do it. Okay, you do what works best for you, but I'm just showing there's a couple of ways to do it. So yes, there is 21. What is our constant once again?
3.
Yes. All right, now they're asking, what if you have 27 quarts of strawberries? Remember, our column for strawberries is on the right. How many quarts of blueberries do you need? Alice, you got it. 9. Okay, go to this page. We're going to kind of do this together because of time. All right, let's look at the given ratio. Imagine that you're making a fruit salad again. For every quart of blueberries you add, you would like to put in 3 quarts of strawberries. What is our given ratio? No. Yeah, it's still the same. It's still 1 to 3. So far, it looks like table 1, but look at the directions this time. Table 2 should contain amounts of blueberries between 10 and 50. Before it was less than 10. So let me ask you this. Is 10 in between 10 and 50? We could use it. Is 20? Is 30? Is 40? Now build this side. And remember, the ratio is still 1 to 3. Don't make it more complicated than it needs to be. Sal, what do you got for quarts of strawberries when there's 10 blueberries?
Since it's 1 to 3, I got 13.
Be careful, because 10 to 13 is not an equivalent ratio for 1 to 3. Charles, is 10 to 30 in this an equivalent ratio for 1 to 3, everybody? It certainly is. What about 20? C squared.
60.
Is 20 to 60 in the ratio of 1 to 3? Absolutely. Well, they're divisible by 20, and you'll get 1 to 3. What goes here? Yup. Finally, what goes here? Will. And in case you didn't notice, they kind of give you the answers at the bottom. You see it? What? Only this is between 10 and 50. That's what. Well, then that's kind of why I do it with you, because I'm hoping that I can get it done before you realize the answers at the bottom. But as you'll see now, the additive structure for this new ratio table is different than it was for the first. What are you adding by going down on the left side? And there is going to be a point to all this here in a minute. John? Yes. Plus 10 on the left. So we could say the additive structure on the left is plus 10. Fill that in on the bottom. Put your plus 10 in that box too. And then flip the page and do the right side additive structure. Okay. And what's the additive structure on the right side? Kristen. Good. We can say that the additive structure for the entire table is plus 10 plus 30. What about the multiplicative structure? Again, we are looking at the values as we go across the columns within each row. Aiden.
Times 3.
Hey, how about that? It hasn't changed. That is why they call it a constant. The additive structure can change. The multiplicative does not, as long as the given ratio is the same for the two tables. And then finally, kind of the gist of this whole thing, for some of you, you'll get it right away. And some of you will be like, I may need to show it to you again. Going back to table 1 for a minute. Put down table 1. What was the additive structure of that table? Antonio?
It was like just a whole.
Of just table 1, the additive structure for each column, yeah.
The additive structure was right,
Yeah, go back and look at it if you have to.
and 3, and 1.
All right, say order matters. Left to right, what was it?
What do you mean? Like,
On the left, on the right.
on the left it was 1, and on the right it was 3.
Okay, put that on your sheet for a minute. Everybody, do that. For table 1, what was the value of that ratio? Chaz? 1 to 3. Table 2. What was the additive structure? Liam? Yes. I'll let you get caught up because here comes the punchline. What's the value of the ratio? Jen, what do you notice? Antonio.
I noticed that table 2 was the same as table 1, just you added zeros. Table it was just 10s.
Okay, that's a good observation. Let's take it a step further. What do you notice? Aiden.
Every number in table 1 was multiplied by 10 to equal everything in table 2.
True. One more other thing that I need you to kind of realize, though. Sal, what do you think?
Both tables have the same value.
That's true also. Liam? Jazz?
They're also the ratio.
All true. Everything that you're saying is true. No disagreements whatsoever. I want you to realize one more other thing. If there was time, I'd have you build another ratio table in the ratio of 1 to 3. Antonio?
They all have the same common, like the times 3.
This is true. That is also true. It has the same constant. Olivia? Last guess, because I'm gonna kind of have to lead you down the path a little bit.
On both sides, if you want to get like for blueberries to 50 and for strawberries to 140, then you can multiply or add them.
You can. Angelina, last guess.
If you would have continued table 1, 10 to 30 would have been in there.
It would have been. That's true too. Here's what I'm trying to get you to say. Your additive structure is 10 to 30, right? If I were to ask you to find the value of a ratio 10 to 30, what would you get? Every table's additive structure reduces to its value of the ratio. That's kind of what I was getting at. And I'm not going to have you build this table, but I just want to show it to you. What if I gave you a table, again, same thing, 1 to 3 ratio. Ready? 2, 4, 6, 8. Let's do it real quick. What does this become? 2 times 3? 1 to 3. Our constant is 3. Let's do it real quick. 4 times 3. 6 times 3. 8 times 3. Now watch. Let's do the additive structure. What are you adding by?
2.
2. What are you adding by?
6.
What's the value of a ratio that's 2 to 6? The additive structure of the table always reduces to its value of the ratio. Like I said, some of you will be like, Oh, I got it, of course. Some of you are like, I don't quite got it. It's okay. We'll revisit it. Okay? Here's what we need to do. We're going to do this one together. This is, what page is this? 6. Okay. One of these values in this ratio table is incorrect. Can you find the incorrect value? And you could use either additive structure or multiplicative structure to figure this out. Take a look at it carefully. One number, I'm not going to, one number is not right. All together, you have 8 values in that table. One of them is not correct. Tristan, what do you think?
Well, it's multiplying by 8.
Okay.
7 times 8 is 56, not 52.
All right. If we assume that our multiplicative structure is 8, it will work for every value except for 1. 3 times 8 is 24. 5 times 8 is 40. However, 7 times 8 is not 52. What should it be?
56.
Put in 56 for right now. 9 times 8 is 72. Let's just make sure it works with additive, with additive structure. What are you adding by? Plus 2. What are you adding by?
16.
It happens to be 16. If this 56 is correct, then 40 plus 16 should be 56. Is it? So we look like we have the missing value or the incorrect value. Is 56 plus 16 72? Yes, it is. So therefore, our ratio table needs to be this. To get caught up, what's the additive structure? I'm kind of hoping to see more hands. If you know it, raise your hand. That way I know. Chris, what's the additive structure?
Plus 2 plus 16.
Yes. 2 and 16. You don't even have to put the plus sign. What's the multiplicative structure? John. Right. What's the value of the ratio? Charles. Nope. Every additive structure, every table's additive structure reduces to its value of the ratio. What number goes into both 2 and 16? 1 to 8. Every additive structure reduces to the value of the ratio table. Okay?
I get it.
And even if that doesn't make sense to you, you've done value of ratio. So you take your first ratio, 3 to 24, and you reduce that to 1 to 8. They're both divisible by 3. And that's kind of the reason why we will be doing it every week in your weekly review. I want it to come naturally to you.
Can't you use it 3 and 24 to find the value?
Absolutely. Yes, you can. Yes, you can. Okay. You guys are going to do B on your own, but I just make a little note. There are 2 mistakes that you have to find in B. You're going to do this in your groups, but I have to do Ball Orchard. And before I let you do it, I want to tell you that your exit ticket needs to be changed a little bit. Can you go to your exit ticket? Number 10. Yeah, you're probably going to run out of time, but go to your exit ticket. What time? It's 45, right? I'm probably only going to get through half of Ball Orchard. I'll do the rest on Monday. But that's okay. It was a teaching day. On your exit ticket, first thing I want you to do is everybody fill out your heading.
Wait, what number?
10. Fill out your heading so there's no problems, no issues. And then here's the change. My changes are in red. I want you to add a line for additive structure and multiplicative structure because it's not on there. And I want you to know it. The question is fine. I still want you to answer the question. I just want you to add additive and multiplicative structure underneath the table. So when you do it, I need you to do that as well. Additive structure, multiplicative structure. All good? All right, when I call you up for Ball Orchard, I need your homework from last night and your review sheet. You need both. Okay, get in your groups and go.